Welcome, Pioneers. Here's our second AFDA video on exponent properties. We have three problems here, and each of these three problems gets at a different exponent property. Let's get started. For number one, we have 2x cubed y times 5xy to the negative 7 power. So normal numbers like 2 and 5, it's just as you would think. 2 times 5, that gives us 10. But with the x terms, when we multiply same bases, we can actually add their exponents. So for the x terms, we have x cubed times x to the first power. Well, we add 3 and 1 to give us x to the fourth power. For the y terms, similarly, 1 y to the first power times y to the negative 7 power. Well, 1 plus negative 7 is negative 6. Great. Number 2. We have t squared all divided by 4t to the 8th power. Let's see what this is equal to. Well, when we divide like bases for the t's, we subtract their exponents. That would give us t to the negative 6th power. But then what about the number? We just have a 4 on the bottom. Well, imagine t squared, we could just have that as 1t squared. Nothing wrong with that, as we've said in class. Well, now we can see a little bit easier that this is really 1 divided by 4, or 1/4 t to the negative 6. So this is fine. Or, here's a different way to represent this. We can see that we have t squared in the numerator of the expression and t to the 8th in the denominator. Well, we could also have almost like canceling out 2 of these t's, which would make this only 6 on the bottom. So we could also have 1/4 t to the 6. So we could have t to the negative 6 if we keep the variable outside of the denominator, or if we want to keep the variable in the denominator or the bottom of the fraction, we could keep the exponent positive. So positive 6 in the denominator. Positive 6 in the denominator, exponent is the same exact thing as saying negative exponent in the numerator. Both of these are equally good answers. Number 3, we have 3m squared z cubed all divided by h, and that entire quantity cubed. This is that second level exponent we talked about. And we learned kind of a shortcut, just in case we don't want to write this 3 times and multiply it together, because that's what cubed means. We learned that it's almost as if we can distribute, not really distribute, but almost as if we could distribute the 3 as an exponent. And we could distribute this cubed down to the h as well. Let's see what this would get us. Well, 3 cubed, because the cubed kind of distributes down to that 3. M, and this is the trick for the second order exponents, we multiply these together when we have that higher level exponent. Because it's m squared, all of that cubed. That's going to give us m to the 6th power. And we have notes on a little more on that if that confuses you. And then following would be z to the 9th. 3 times 3 is 9, all over h cubed. We're almost done. Not quite. Because can we simplify 3 cubed just a little more? Well, what is 3 cubed? 3 cubed is the same thing as 3 times 3 times 3. That's what cubed means. Just multiply it by itself 3 times. So 3 times 3 times 3, or 3 cubed, is 27. M to the 6th power, z to the 9th power, all over h to the 3rd power. And we did it. So, we did 3 different properties of exponents. Adding exponents when we're multiplying those monomials, subtracting exponents when we're dividing monomials, and finally the second order exponent, where it's an exponent raised to another exponent. We multiply the exponents. I hope this was helpful. Let me know if you have any questions.